And you're back. Awesome. Okay, it's time to look at multiplying matrices now. And yes, it's still about the order of the matrices. This one is even more important. You have to get this right. There is a specific rule we have to check for. Speaking of orders, let's do a quick recap. Order of a matrix. Okay, now the order describes the dimensions of a matrix, and it's always the number of rows by the number of columns. In this case, you can see across the way, there are 3 rows and there are 5 columns going down the way. So we say this is a 3 by 5 matrix. Remember that? Awesome. Now, there's 2 types of multiplication. There is the first one called a scalar multiplication. Now, that is where we take a whole number. Oh, no, sorry, it doesn't have to be a whole number, a number. It can be a fraction, it can be a decimal, it can be a negative, but it is a number, and we multiply it by everything in the matrix. That one is really straightforward. Let's have a look at it. Here's a matrix, and we're going to multiply it by random number generator in the background. Let's multiply by 6. Okay, 6. 6 by each of those numbers. Straightforward. So let's go. This is a 2 by 2 matrix. Our answer is also going to be a 2 by 2 matrix. So we do, believe it or not, 6 times 3, which is, of course, 18. Then we do the 6 times a 5, which gives us 30. Then we do the 6 times a 2, which is 12. And lucky last, 6 times 1 is, think about that one for a second. That's a toughie. 6 times 1 is, well, 6. Yes, that's it. That's as hard as scalar multiplication is. That 6 just makes the whole matrix get 6 times bigger. Straightforward. Where it gets a little more complicated is multiplying matrices. And in year 11 and year 12, you have to be able to do it 2 ways. First way, you need to be able to do it manually, and you have to recognize whether it will work. And you also have a CAS or a class pad, and you can just type them into, if you just need an answer, you type the matrices into your calculator and you will get an answer. Straightforward. But you do have to know how to do it manually because you have to be able to explain what's happening. All right, let's have a look at a couple of matrices. Now, if we were adding and subtracting these matrices, could we do it? No, we couldn't, because this first one is a 3 by 2 and this second one is a 2 by 2. Remember, when you add and subtract, they have to be exactly the same order. This is multiplying, though. Multiplying, there is a specific rule. It says, sort of this. If the inside numbers of the orders match, an answer matrix is defined. Well, let's have a look. There's the inside number there, and there's the other inside number. They're the same. That means we can do it. But do not, under any circumstance, use the word words inside numbers. Do not. Use the right language, please. The right language says, if the number of columns in the first matrix, which is the 2, is equal to the number of rows in the second matrix, which is that 2, then an answer matrix is defined. Okay? Always talk about the number of columns in the first and the number of rows in the second. So you could say that the number of rows in the number of columns in the first matrix is 2, which matches the number of columns in the second matrix, which is also 2. Therefore, an answer is defined. Something like that. Got it? All right, use the right language. Okay, now what do we do? Well, one more thing we get out of these orders here is, well, there's a 3 out the front. There's a 2 out the back. Now that gives us a bit of information too. That gives us the order of the answer matrix. So can it be done with the columns and the rows there too? Yes, it can. And our answer matrix is going to be a 3 by 2. Here it is over here. So we're going to end up with a 3 by 2 matrix. So let's do a 3 by 2 matrix. Nice big one. Now, other bit to remember, how do we talk about the order of a matrix? It's always row by column, rows by column. This is a bit you've got to pay a lot of attention to. I like to, and particularly when you're learning this, label the positions in our answer matrix. So if we were going to put a number up here, what position would that be? That would be the first row and the first column. So write a little 1, 1 there. What would this spot over here be? That'd be row 1, column 2, wouldn't it? And so on. This one would be row 2, column 1. So 2, 1, and position 2, 2. And this one would be, of course, 3, 1, and 3, 2. So that's just a little label, just do it small. It's a little label to tell you which row and which column you are going to multiply, because this is a 2-step process. All right, this is row 1, column 1. So we're going to take row 1 of the first matrix, which is across there, and we're going to multiply it by the first column of the second matrix. Does that make sense? Row 1, column 1, row 1, column 1. So how we do that is we take our number here and our first number here, and we do 3 times 4. That bit's straightforward. Plus, now this is what we have to do, plus the second number here and multiply by the second number here. So it's going to be 3 times 4 plus the 5 times the 8. So we do 3 times the 4 plus the 5 times the 8. Okay, see how it's first column, sorry, first row, first column, the second number. That's why these inside numbers have to match up. 3 times 4 is 12, 5 times 8 is 40, so the answer there is 52. Let's go across the way. Row 1, column 2 now. So we're going to keep it at row 1, but we're going to shift this one across to go to column 2. So we do our 3 times the negative 2, plus we're going to do 5 times the 1. So 3 times negative 2 is negative 6, plus 5 is negative 1. See how this is happening? We'll do this one now, row 2, column 1. So bring this one down to row 2, and we'll bring this one across to there. Oops, skipped ahead a little bit. Sorry about that. 2 times the 4, obviously. 2 times the first one, and we're going to plus the 1 times the 8. 2 4s are 8, 1 8s are 8, so it is 16. 2 2, let's bring this across. First times the first, 2 times negative 2, and second times the second, 1 times 1 is 1, of course. So that's negative 4 plus 1 is negative 3. 2 to go. Where are we moving to? 3 1. So row 3, column 1. So row 3 and column 1. There we go. You can see easily now. 6 times the 4 and plus negative 1 times 8. So that's 24 minus 8 is 16. And lucky last, 3 times 2. Oh, sorry, not 3 times 2. Row 3, column 2. So shift you across. There we go. 6 times negative 2 and plus negative 1 times 1. So that is negative 12 minus 1 is negative 13. All right. Think you can follow that process? All right. Good time to get practice. I know when you're doing it with pen and pencil, you haven't got circles and you can shift across and stuff like that. Might be a good idea, though, if you use a rubber or a pencil and cover up stuff that you're not doing, just till you get the process of row times the column. Okay, so steps, summary, check that the orders are right. The columns in the first matrix match the rows in the second matrix. Then cover up the ones you don't need. You lay out, sorry, here I am pointing at a screen, you lay out which position is which, and then you multiply the row by the column and add the two pairs in between. Okay? Straightforward. Go get some practice. Pause this video, go through it if you need to. Once it gets into your head, it becomes quite natural. All right. Have fun.